So following that, the next thing we talked about in Unit 5 was isosceles triangles. And so just as a reminder, isosceles triangles have two congruent legs. And because they have two congruent legs, we also know they have two congruent base angles. All right, so we're going to solve two problems with isosceles triangles. The first one looks like this, and it says find the measure of angle y. So we're going to try to figure out a missing angle. All right. Notice here how we have 4x and 80 and 3y minus 40. Well, our goal is to find y. So if we tried to add all these up and set it equal to 180, we would have x's and y's in our equation, and it just wouldn't work. So 4x is a distractor. We do not want to use that piece of information. But because it's isosceles, we know the base angles have to be the same. So since angle A is 80 degrees, we know angle C is also 80 degrees. And now we can use our triangle sum theorem, and we can add all three of our angles together and set it equal to 180. All right, so from here, we got some combining to do. So 80 plus 80 minus 40. So when we combine those, we get 120. So that's 3y plus 120 equals 180. And then we're trying to solve for y, so we want to get the y by itself. I'm going to get rid of positive 120 by subtracting it from each side, because those would cancel out and give me 0. So I can just bring down the 3y, and then 180 minus 120 is 60. Divide each side by 3, and y equals 20. And that's actually what the question asked for. It said find y. If it had asked for the measure of angle B, you would go and plug that back in to figure out the measure of angle B. We could have done this another way as well. If we know that both of these angles are 80, we could have added those up to begin with, and we could have subtracted from 180 to figure out that this angle had to be 20. So it's kind of crazy that the whole angle B equals 20 as well as y equals 20. So I wanted to go back and check my work just to make sure I wasn't going crazy. But if you do set that equal to 20, then you still get y equals 20. So anyways, there was two ways you could have solved that problem. Let's check out one more isosceles triangle problem. This statement says, I can use the properties of isosceles triangles to find the lengths of sides. So this one says, what is the length of side AC? So this one is our ultimate goal. Okay, but to start off with, we don't know anything about that. All we know is it's an isosceles triangle, so we know this leg is congruent to this leg. So even though I ultimately want to solve for AC, I'm going to start off by setting the two legs equal to each other, because we know in an isosceles triangle, the two legs are equal. All right, then we're going to solve for x. So 5x's minus 2x's is 3x. I'm going to plop the plus 5 straight down as well as the 20. Trying to get x by itself, so I need to get rid of positive 5. The opposite of that, or the inverse, would be to subtract 5 from each side. And then lastly, I have 3 times x. The opposite of multiplying is dividing. So I get x equals 5. Okay, but remember the question didn't say solve for x. It says what is the side length of AC? So now we're going to take what we got for x and we're going to plug it in to AC. So I'm going to take 9x minus 5 and I'm going to substitute in what I solved x to be. So 9 times 5 is 45, minus 5 is 40. So the length of AC is going to be 40 units long. Okay, so that one was kind of a weird problem, only because you wanted to find AC, but you couldn't use it when you started your equation. You had to use the two sides that you knew were congruent.